so here we have a related rates problem which states a spherical snowball is melting, its radius is decreasing at 0.2 centimeters per hour when the radius is 15 centimeters. How fast is the volume decreasing at that time? So the first thing we should do is just simply sketch out a picture. So we know snowball is like a sphere, and then we can just label what we know. We know that the radius is 15 centimeters. So we're trying to find the volume of sphere, so it's important to know the volume formula for it, which is 4/3 pi r cubed. So now that we've got that, we should identify what we know. So like the quantities that the problem states, and then what the quantities we're trying to find. So we know that the radius is decreasing at 0.2 centimeters per hour. So that would be r prime, because that's the rate of change of the radius. So that would simply be 0.2 centimeters per hour. And let's not forget to put the negative because it's decreasing. And then we also know that the radius is 15 centimeters. And we're trying to find how fast is the volume decreasing at that time. So we're trying to find the rate of change of the volume. So that's what we don't know. And in order to find that, we have to take the derivative of volume. So for that, we leave the 4/3 pi, and then we're going to have to apply the chain rule to r cubed. So that would make it 3r squared times r prime. And so then we can simplify that. So 3 times 4 is 12, divide by 3 is 4. So that's 4 pi r squared times r prime. And then we can just go in and plug in what we know. So we know r is 15, and we know r prime is negative 0.2. So when we work this out, we'll get v prime is equal to 4 pi, 15 squared is 225, and then times the negative 0.2. And so that would equal negative 180 pi. So our answer would be 180 pi centimeters cubed per hour. And we leave out the negative because the problem already states that we're decreasing, so it's not necessary.